Are you an IT pro that works with AWS cloud security and you like working with Terraform as well? If that's the case, then this video's for you. Before we get into it, make sure you like and subscribe to this channel so that you don't miss anything. Now, in this video, what I'm going to walk you through is how to use Terraform to configure an AWS security solution. What we're going to do is we're going to use GuardDuty to produce some threat detection findings, and then we're going to automate some remediation based on those findings. Now, before we get into the configuration, let's take a look at the architecture and we'll see overall what we're going to accomplish as we work through this tutorial. This is an example of our starting infrastructure. Now, in our environment, some things have already been prepared for us so that in this video, we can get right into the configuration that matters, the Terraform. What we've already done is we've already created a VPC inside of our region. That VPC has a public subnet in it, and inside that public subnet, there's an initial security group that has two EC2 instances in it. The EC2 instances, for demonstration purposes, are called compromised instance and malicious instance. Now, in no way are these instances compromised, nor are they malicious, but we're running some scripts on these machines so that they communicate in such a way that we can produce a GuardDuty finding to illustrate how this process would work in the event a real threat activity were to take place and you wanted to match it and perform some auto remediation. Now, as we go through the configuration, we're going to end up with this final solution. Our final solution is going to have a second security group called Forensic Security Group that our compromised instance gets moved into. As the compromised instance and the malicious instance communicate with one another, GuardDuty will produce a finding. When GuardDuty produces a finding based on information that it's pulling from our VPC flow logs, it's going to match an EventBridge rule. That Amazon EventBridge rule is going to trigger a Lambda function, and that Lambda function has some Python code that's going to move the compromised instance from the initial security group to the forensic security group. So let's go ahead now and dive into our environment. I'm going to start off my configuration in the AWS Cloud9 IDE. I'm going to be working with Terraform modules, so you'll need to be familiar with that. And I'm going to start out in my S3 module. These folders have been pre-created for me. I'm going to go to the variables.tf file, and I'm going to add a variable for the VPC ID. But first, let me just clear up a little bit of space here so we can focus. And let's go ahead and create a variable called VPC ID. I need to save this. In fact, after every time I configure something in one of these files, I need to go in and click on save, or I could do Command S, and a little green dot will appear there, and that'll indicate that the file's been saved. Okay, so now that I have the VPC ID, the next thing I'm going to do is I'm going to go into the main.tf file for the S3 module. So I'm going to click on main.tf, and it's in here that I'm going to create my S3 bucket. We'll use this S3 bucket for a couple of things, but the first thing I need to do is get my AWS account number, and this will end up being used in other parts of the configuration. Next, I'm going to create an S3 bucket. An S3 bucket is a Terraform resource. So I create the resource. We're going to give the bucket a name, GuardDuty example, and then I'll put my current account number ID in there, US East 1. I'm telling it to force destroy in this case. And the reason this is important is because whenever I do a Terraform destroy, I want it to actually delete the S3 bucket, but if there's stuff in the bucket, it won't destroy it. So I'm forcing it to destroy that bucket whenever I do a Terraform destroy. Okay, so the next thing I'm going to do is set up my VPC flow logs. This is another resource in Terraform. I need to define the log destination is going to be the S3 bucket. The destination type is S3, the traffic type is all traffic, and the VPC ID is going to pull in the VPC ID from that variable that I set. And make sure we save. Now let's go to our outputs file and let's output a couple of values So we're going to output the bucket ID, and we'll go ahead and define what that value will be, give it a description here. And then the next thing I'm going to do is I'm going to output the bucket ARN, define the value. We're pulling this from inside that main.tf, and I'm going to output the S3 bucket ARN. Now we have our S3 configuration. Again, make sure that we save our outputs file. When we create a module for Terraform to apply it, we need to add the configuration in the root main file. So that's the next step in our configuration, is to add this S3 bucket configuration to the root main. So let's go over here and open up the main.tf, which is in the root of our directory. You can see here I'm working with root/main.tf. It does have some pre-configuration in it. We're not going to cover that in this video, but we are going to go down to the bottom and we're going to add our newly created S3 module. So this is what's going to create the S3 bucket when we apply the Terraform. So we define the module, the source, which is modules S3, and then the VPC ID, we're pulling it from the VPC module. It's being output by the VPC module, and then we're using it as a variable in our S3 module. And of course, we don't want to forget to save, so do a Command S at this point. Now we're going to enable our GuardDuty configuration. So we're going to work within the GuardDuty module. We'll build our configuration there, and then we'll add that module to the root main before we apply the Terraform configuration. So we need to navigate, again, under our modules directory into the GuardDuty module, and then to the main.tf. Let's close out a couple of these other files so we kind of keep this clean. Again, in the modules, GuardDuty main.tf, we have that, we have outputs, we have variables. We're going to work in all three of these files, so I'm just going to open them up. Let's start by defining a variable. We're going to define bucket and malicious IP, and these will be values that get output from other modules. We'll use them in our main.tf configuration here in the GuardDuty module. So let's enable the GuardDuty detector. This is a resource, so we're going to define that resource and enable this true. And then we're going to set the finding publishing frequency to 15 minutes. By default, it's an hour. We're just going to speed that finding publishing frequency up as much as we can. 15 minutes is the lowest value we can set. Now we're going to add the elastic IP or the malicious IP to the bucket. Now this is a value elastic IP address that's assigned to the malicious host, and we're just going to use that elastic IP address to add to a threat intel list that we'll define as being malicious. It's just a way for us to manipulate the GuardDuty findings. So I'm going to have GuardDuty look at that text file in S3, and this is where it's going to find the IP address, the elastic IP address that we've assigned to the malicious instance in EC2, which we didn't show you in this video. It's been pre-configured for you. So we'll take a look in the console later on at where this threat intel set is defined. But again, we need to save, and then we need to come down here to our main in root, and we need to define our module. So we're going to enable GuardDuty by defining the module, defining where the module is located. We're going to define the bucket information, the malicious IP information. Remember, these are being output from those other modules used as variables in the GuardDuty module. So this is what we need to do. We need to also save, and now we've got GuardDuty configured here. Now we're going to start to build our Lambda function, which is going to move us to a new security group once we've identified a finding in GuardDuty, a specific finding. But before we do that, let's just close out some of these files. We don't need to have all of them open, so we'll just clean this up a little bit. Now we need to navigate over to our Lambda module. In our Lambda module, we're going to go to the main.tf, and then in this main.tf, we'll set up our Lambda function. So first, we're going to create a policy document. This is an IAM policy document, really defining the trust relationship for the policy. So you can say we're saying AWS IAM policy document, giving it a name, and then we'll define our statements here. So we're going to allow an STS assume role for the Lambda service. Next, let's create our role policy. This is going to be our inline role policy that will be applied. Let's go ahead and provide it a name. And then let's define the role. And then let's define the policy. We're going to do this with some JSON code. And as we define all of our allowed actions, we'll speed this up just a little bit to get through it. So as we speed this up, just know that what we're adding here are the actions that are going to be allowed when the role is assumed. Okay, so we've got all of those in. The next thing I'm going to add is another resource. This resource is going to be an IAM role. We're going to call it GD Lambda EC2 malicious IP caller role 1, and we're going to tell it what policy this role can assume, and it's that policy that we just created. Now let's take a look at the code that we're going to send up to Lambda. So we go into our code folder, open up index.py. This is the Python code that we're going to use, and the most important piece of it is the try block. So let's just scroll down here a little bit and take a look at the try block, and let's define what it does. So here we're going to use Boto3. Now Boto3 is the name of the Python SDK for AWS, and it lets us directly create, update, and delete AWS resources with our Python scripts. What Boto does essentially is call the AWS API on our behalf. So it's going to do that from Lambda. Now for most AWS services, Boto3 offers two ways of accessing these APIs. There's client and there's resource. Now client is for low-level service access, and that's what we're doing here. So I'm going to use Boto3's client function to communicate with EC2. Now remember, we want to move the security group that's assigned to our EC2 instance. So what we're going to do is first we're going to set a few variables. Let's focus first on the instance ID. What we're doing is we're getting from the event the instance ID. So when GuardDuty had a finding, and that finding went to EventBridge, which then triggered the Lambda function, that finding had an instance ID. We need that instance ID. Then what we're doing is we're making sure that that instance ID is the same as the instance ID that's coming from an environment variable. And if it is, then we're telling Boto3 to isolate the instance. So we say that we're going to do an instance.modify attribute, and then we change the security group ID. The security group ID is this variable right here, and we pulled that out of our environment variables as well. Okay, so that's what happens in this script. Okay, so let's go ahead and close this file now. And then what we're going to do is we're going to add an archive file. We're basically going to have the file that we just looked at zipped. We'll define that source file and the output path, and then this index.zip file is going to be uploaded to Lambda. Okay, now we're going to define our Lambda permission resource and give it our statement ID. Right. And then we're going to tell it that the action is to invoke the Lambda function. We'll define the Lambda function name. And then the principal, which is going to be events.amazonaws.com, which is EventBridge. Okay, now that we've got that, we'll save that file, and then let's go into our variables file within our Lambda module. And we're going to define our compromised instance ID variable and our forensic security group ID variable. Save that, and let's move back over here to our main.tf inside of our Lambda folder. And let's create the actual function resource. So we're going to create a resource here. We'll give it our name here, the function name, GuardDuty example remediation, and the file name, which is index.zip, and our source code hash, we'll define that, which is going to be a SHA-256, and the role that'll be used to invoke this function, and the handler, and the timeout, and of course, define our environment variables, And you saw us call these environment variables in that Python script when we walked through it. Okay, we'll save that. We'll go to Outputs. We're going to output our Lambda remediation function ARN. Define the value here. And we need to save that. And we can go ahead and now go into our root main, and let's go ahead and add the Lambda function. So we need to tell it where the module is. It's the Lambda module and the source. We'll define the compromised instance ID. We're going to get that from the compute module. The forensic security group ID, we're going to get that from the VPC module. And of course, we need to save that. So we can go ahead and close these out because our Lambda function is now done. And let's just collapse that. And now let's go into EventBridge, and we'll open up the main.tf, and let's create our event rule resource. And you'll notice it's still called CloudWatch event rule. This is EventBridge now, but we're going to give it a name and a description, and we'll just populate that as the unauthorized EC2 malicious IP caller.custom. That's what we're looking for. And then we're going to define the event pattern. So the source is going to come from GuardDuty. The type is going to be unauthorized access EC2 malicious IP caller.custom. And then we'll create another resource here. This is an event target. So we create the rule. Now we're creating the target. So we reference the rule, and now we define the target ID is GuardDuty example remediation and the ARN. And now let's go over to our variables file. We're going to create our variable called Lambda remediation function ARN. And now we're going to go to our root main again, and we're going to create the EventBridge rule. Again, we need to reference the module, the source, which is defining where that module is at. The Lambda remediation function ARN, we're going to get that from the Lambda module. We've already created that. And we need to save. Now we've got our entire configuration. Let's open up a terminal, and let's go ahead and apply this. We'll close these out just to make it clean. And we're going to issue our Terraform commands. So we'll do a Terraform format recursive, and we'll just format all of our Terraform files, and we'll clear that. And then the next thing that we're going to do is we're going to do a Terraform init, because we've created new modules we need to do an init. And then we'll clear that. We're going to go ahead and do a Terraform plan, and let's see what Terraform is going to do for us. So Terraform is going through, figuring out what it's going to do. It's going to have 11 to add. We're not changing anything. Let's clear that. And let's do our Terraform apply. We'll auto approve this one. And now we're actually using Terraform to interact with our AWS environment as we apply that entire configuration. So we'll let this apply now. And then once it's applied, we'll jump over into the AWS console, and we'll just verify those elements and make sure it's configured the way that we expect it to be configured. And it's finished. 11 were added. Let's go take a look in the AWS console and see what we got. I'm going to start out here in GuardDuty, and this is a list of the findings. And right now I only see one. So what I'm going to do is I'm going to click on that finding, and it'll open up this panel on the right-hand side. And from here, we can scroll and we can see different details about this finding. We can see the resource that's affected. We can see details about the instance. As we scroll down further, we can see network interface information, private IP address information, and yes, even the security groups that are currently assigned, in this case, the initial security group. So that's exactly what we expect to see in our initial configuration. So again, lots of information here in this panel within GuardDuty for you to take a look at. And of course, we can act on that information. All right, so next, let's take a look at our settings. As we scroll down here, we'll stop right here. This is our export option. We're going to export every 15 minutes. Now, the default for this is 1 hour. Recall that we did lower this to the lowest value possible, which is 15 minutes, so that we export that information and then EventBridge can see it. Okay, so as you can see, if you scroll down, you can suspend or disable GuardDuty. Let's go over here to the list, though. Remember, we created a threat IP list. It's called My Threat Intel Set, and it's pointed to S3. This is where the IP address of the malicious host is going to be. This is how we get GuardDuty to trigger the finding for us in this case. We open that up, and it'll show us the S3 Threat Intel Set bucket. We'll close that. We're not going to open up the file. We're not concerned with that right now. But let's go ahead and move on to now EventBridge. That's the service I want, so I'll hit Enter. Now that we're in EventBridge, on the left-hand side, I want to go to Rules. This is where I'm going to find the rules that I created, and I'm just going to search for GuardDuty just to filter out the one that I want to look at. So let's go ahead and look at the GuardDuty rule that was created by Terraform. And I'll scroll down here. This is the event pattern. Now, we did define this in our Terraform configuration, so it's looking at GuardDuty, and it's looking for that specific type of event pattern to be reported, and that's coming from the finding. Let's go back to GuardDuty and just confirm that. We'll open this in another tab. And so here it is, unauthorized access, EC2 malicious IP caller.custom. That's exactly what we're looking for here in EventBridge in our event pattern. We can see that right here. Okay, so now the target. What happens when we see that? Well, remember we created that Lambda function. Here it is. And of course, this will fire off when we have a matched event. Now, there's a couple ways that we can get to the function to take a look at it. We can either click right here on the target name and it'll open up. It's doing that in another window here. It takes us right into the function. Another way we could do it is if I just come back over here is just to search for the Lambda service. We'll go ahead and access it. We have a couple of functions here. The one we're concerned with is the one on the bottom, the GuardDuty example. We can click into that. Now we're going to be looking at the exact same function as the one that we got by clicking on the target name. So we'll close one. We don't need it. This is the code source. This is that Python script that was uploaded. So we already took a look at how this works. But remember, inside here, we had a couple of variables, and those variables were going to get some values for us, our instance ID and our security group ID. And when I look at the configuration, I can see that it has pulled those values from my AWS account. So it has that information to execute that script. Let's go over to EC2 and take a look at the two instances that we've been working with, the compromised instance and the malicious instance. So I will click on the instances running link, shows me the 3 instances. Of course, this is that compromised instance. It's the one I want to focus in on. Let's look at its security group. So if I scroll down, it's already been moved to the forensic security group. So the rule worked exactly the way that we expected it. When we looked at the GuardDuty finding, which is what we're going back to right here, recall that the GuardDuty finding showed that we were in the initial security group. Okay, so we're not going to go into the finding, but let's jump over to EventBridge again. I'll show you one more place that we can go look. And again, I'll search for GuardDuty. So we filter, and let's look at that GuardDuty rule, and let's go to monitoring. And as I look here in monitoring, we can actually see that it actually did invoke that Lambda function. And that'll do it for this tutorial. As you can see from this video, we've been able to take Terraform and configure an AWS solution using GuardDuty to produce threat findings and tie that together with EventBridge and Lambda so that Lambda can take some automated actions for us. I do hope that you found this useful. Thank you for watching.